So today we are going to demonstrate fish protein isolation, how we can do. Okay. So as we know, like last practicals what we have done, chitin extraction. So the chitosan how we will do that also we will be doing today, and we will be keeping it for drying. Okay. So after that we will be extracting protein. Okay. So as we know, fish protein is alkali soluble in nature. Okay. So for that what we have to do, like we already collected the fish sample. So for the easy extraction and in order to reduce the time, we will be making it into a paste first of all. Okay. So after making to the paste, we will be solubilizing the protein into alkali solution. So we will be taking 2 normal NaOH. Okay. So for that anyway we need some water. Okay. We will be taking the fish sample and we will be making a proportion as 1:5 ratio. Okay. 5 gram of fish and 500 ml of water. Okay. So after that we will be mixing it together and we will be adding NaOH to make it to 10 to 14, the pH in the range of 10 to 14. Okay. So most of the protein will be solubilizing in it. So nearly 12 we will be taking an average. So most of the fish protein will be solubilizing. So non-soluble protein will be that we can't do anything as of now, because there are a lot of, like it's again we have to go for next procedures and it will be too complicated. So for that, first of all we will be taking the sample and we will be adding water. Then better to done this process in lower temperature, so the protein can be easily solubilized, okay, without coagulation. So after that we will be solubilizing the fish paste into this alkali solution, that is 2 normal NaOH solution, and after that we have to centrifuge it. Okay, we have to centrifuge the sample. So then in which portion we can take after centrifugation? Supernatant, because solubilized part will be always there in supernatant top. Okay, so the supernatant again we will be taking out, and the centrifugation can be done at 4 degrees Celsius. So we will try to make it at a 40 degrees Celsius or as low as possible. After that we have to get the protein portion. Okay, so the solubilized protein need to be precipitated. So it can be precipitated by their isoelectric point. So we will be slowly adding acid. Okay, if you are adding alcohol, then it will be very difficult. Like immediately it got solubilized. So sorry, precipitated. So apart from that, we will be adding acid slowly. Okay, so at a point it will get solubilized nearly the pH near to 4 to 4.5, in between 4 to 5 probably. Okay, so in that pH we will be solubilizing it, we will be precipitating it, and again we are going for centrifugation. After centrifugation, what we will be getting? The pellets will be getting, that is the protein, and we can go for NMR if we require to check the purity of the protein. Today as we said, we will be, after demineralization and deproteinization we got this chitin, so we will be converting it into chitosan. For that we have to add what we have to add? NaOH, and we have 2% NaOH is here, and we will be adding it and we will be keep it for incubation. Okay, we will be adding, we will be keep it later. Okay, so meanwhile we will be doing other analysis. So after deproteinization it will be look like this. Okay, you can see. So we can add it now. It's completely solubilized, so it is easy. Okay. So for next one, we have to prepare HCl, that is 2 normal HCl and 2 normal NaOH. Okay, so we already weighed the sodium hydroxide pellets. So we can add. We'll be making only 500 ml because we have to make it into, or we have to convert it into 11%, like 11 pH 11. Okay, or 12. So there is no need of additional noise, so we can conserve it. Okay. So first of all we have to make the solution. Meanwhile, I will introduce you. May have seen this ultrasonic bath. Okay, so it's ultrasonic cleaner. Even we can use it as ultrasonic bath for ultrasonication. So anybody you have used this one before? So what's the frequency? 40 kilowatts. Okay. So even most of the cases in food application we won't use ultrasonic bath, but for extraction purpose we can use. For if you want to change the functional group or for the better effect we will be using probe type ultrasound as sir already discussed with you, right? So this is this can be also used for extraction purpose. Okay. So this is HCl, and we will be making, we already measured this one because otherwise it creates so much fumes. That's why we already measured. Actually we need pH alkaline pH paper. It is till 7 only. It is going to nearly 1 to 2, okay, nearly 1 to 2 as you can see here. This as per the pH strip, okay. So actually the pH meter is in another lab. So in order to prevent the shifting of the everything, that's why we bought the pH paper. For the even for isolation or precipitation, this pH paper is fine because whenever we are adding the acid into it, so slowly it started precipitating. So we can easily get to know like it's about to come, okay. So if you want to do the specific analysis, for that we need to know like at which pH, exactly at which pH it is going to precipitate, okay. Grinded. So first of all we will be grinding the fish into paste, okay. So after that, in that paste we have to add water. So in 1:5 ratio we will be mixing, okay. So 100 gram only we will be taking. So from 100 gram we will be adding 500 ml of water, okay. Then usually we have to homogenize it for the uniform distribution, okay. So homogenizer also we can use because it is a non-veg like fish sample and they are using it for other products, vegetable products. It's very difficult to clean it, okay. We have to entirely dismantle. So we will be mixing it properly. For anyway we will be solubilizing with NaOH. So anyway it will usually go for mixing because for that we will be grinding it as fine as possible into fine paste, okay. So after that we have to adjust the pH into 10 to 14 pH, that is nearly 14. So nearly 12 we will be adjusting, okay. So in that pH we have to go for like that. we will go into the lab. So we can slowly add this NaOH. Anyway, it is already prepared. So before that we have to make the paste. Okay. So they will be making. So just wait for some time. So so as of now, what we have done initially, what we have done. So first of all, we made the paste. Okay, then we solubilized. Okay, we solubilized the sample with NaOH. Okay, and we have to keep the pH between 10 to 14. So we we adjust the pH up to 12, and after that we solubilized properly. After that we centrifuged it. Okay, so after centrifugation, as you can see, it's containing huge amount of protein. Huge amount of protein as well as fat. The top one is fat because low density. Next one is protein, and the other portion which is other residues. Okay, so this middle portion, top portion will be fat, middle portion will be the protein fraction, and the bottom portion will be other debris. Okay, so the middle portion we have to take. Okay, so the middle portion we have to do isolated precipitation at 4.5 pH. So we will be filtering it anyway. So remove the fat. Okay, so without disturbing the bottom pellet, we will be precipitating it. Okay. It's not coming. Coming, man.
Taking time.
No, it won't, like it's because of the fat. Just keep it. Take. We remove the fat layer. No need to feel directly pour.
Remove the fat here.
Take. So we will be removing the fat because it's clogging the filter paper. Okay. So
Now you can
beaker. Okay. No, we'll directly pour now. No need to feel. Not coming. It's
it's coming.
So after that we have to isoelectric precipitate it. Okay. Usually we have to keep it for a long time because then only it will filter properly.
Meantime, we can see this.
So last time that crab was there, no? So their protein soluble fraction is here. Okay, I will show you how it will work. Isolated precipitation. Okay. Beacon.
This is the extra we can do with this one. We can use this one for sowing them.
Precipitation. It's very small quantity, man. We need
Mix 2 times of water.
So as you can see, this is the protein soluble fraction. So whenever we are adding acid drop by drop, we can see how it is precipitating. Okay. So, so we'll be adding slowly. So we can't add directly, we will be adding with droplets, dropper. So see in the top layer you can see the precipitation starting. See? You can see, right? The top layer. Huh? When we keep it for some times, it will be completely precipitated. Okay, after this, we can centrifuge and we will be getting the pellets. Okay, so as you can see, it started precipitating down, like one layer. That is the protein fraction. Okay, so the isoelectric pH, if it is achieved, then it will start exactly at 4.5 or in between 4 to 5, it will be started precipitating. As you can see, it is coming down slowly. So it will take some time. So for easier separation, we will be going for centrifugation. Okay, so that's it.